Okay. Tinry nyo rin bang mag-solve or hindi? Hindi. Mhm. Okay. So, walang nag-try na mag-solve ng problems? Or meron? Okay, sige. Let's see. So, ito yung mga problems na in-upload ko rin dito sa, sa notes. Let's begin with these problems. Okay, so meron tayong meron tayong apat na types ng circuit dito. Okay, so at this point, dapat ma-recognize nyo na kung klase mga circuits to. So yung letter A ay tinatawag na voltage follower, di ba? Yung letter B, anong tawag natin dito? Okay, so meron tayong feedback resistor na nakakonect sa negative. Okay, good. Negative terminal sa inverting terminal, and then another resistor, yung input ay naka-connect dun sa inverting terminal. So ang tawag natin dito ay inverting amplifier. And then ito, ang tawag natin sa circuit na to, tawag dito, sa letter C. Tawag natin dyan ay, so yung input ay nakalagay doon sa non-inverting, yung voltage input ay nakalagay sa non-inverting input, sa non-inverting input. Okay, then you have a voltage divider dun sa inverting input. So ito ay non-inverting amplifier. And dito naman yung huling-huli, this is also an inverting amplifier if you compare it with letter B. So for these circuits, if you have a signal voltage of 10 millivolts RMS, okay, that is applied to each of the amplifiers in the figure, what are the output voltages and what is their phase relationship with the inputs? Okay. So for letter A, this is a voltage follower. So dito ang voltage follower is just a buffer amplifier na ang anong tawag dito? Na ang voltage gain is unity. Okay? So kung ano man yung input dito, yun din yung output. So for letter A, okay, paano natin gagawin to? Sige, try natin kung kasya dito. So for letter A, since ang voltage gain ng voltage follower is 1, then yung V out ay equal sa V in. Since ang V in is 10 millivolts RMS, and then yung V out is also 10 millivolts RMS. Okay. And then ano yung phase relationship with the input? So the voltage follower does not introduce a voltage shift, a phase shift. So the phase shift here is 0. Okay, so kung ano man yung input signal mo is exactly your output signal in terms of yung amplitude and also in terms of the phase. Okay, so next. Here you have an inverting amplifier. And naalala nyo ba kung ano yung equation ng gain for the inverting amplifier? So ang equation ng gain for the inverting amplifier ay equals a negative RF, yung feedback resistance. Yung feedback resistance divided by yung input resistance. Okay. So, ibig sabihin, V out over V in. So, V out ay equal sa negative RF over RI times V input. Ngayon, ang feedback resistance dito is 100 kilo ohms at yung input resistance ay 100 kilo ohms. So this is negative 100 kilo ohms divided by 100 kilo ohms times 10 millivolts RMS. So this is your output. So ang output voltage ay equals sa negative 10 millivolts. It equals at 10 millivolts RMS. So it's unity gain, okay, pero meron kang phase shift na 180 degrees dahil dito sa negative sign, as indicated by the negative sign. Okay, we can do the same for the inverting amplifier dun sa letter D. So yung V out dito ay equal sa negative RF over RI times V in. In this case, ang RF is 330 kilo ohms at ang RI is 33 kilo ohms. So negative 330 kilo ohms divided by 30 kilo ohms times 10 millivolts RMS. So that's your V out. Okay, so ang gain dito is 10. Diba? So ang V out natin ngayon will be negative 100 millivolts RMS. So nag-increase yung voltage by 10. And then dahil as indicated by the negative sign, yung phase shift natin is 180 degrees. Okay. Any questions? Okay, wala. Okay. So, then yung circuit sa C ay yung non-inverting amplifier. Okay, ano bang equation for the gain of the non-inverting amplifier? So the gain is given by 1 plus RF over RI. And ito ay equals sa V out over V in. So ang V out ay equals sa 1 plus RF over RI times V in. Okay. Ngayon, ang RF dito, ang feedback resistance ay 1 mega ohm at yung input resistance ay 47 kilo ohms. So this will become 1 plus 1 0.0 times 10 to the 6 ohms divided by 47 times 10 to the 3 ohms times 10 millivolts RMS. So ang V out ay equal sa 22. Ang gain is 22.3 times 10 millivolts RMS. So ang V out natin ngayon is 223 millivolts RMS. Okay, and since ito ay non-inverting amplifier, ang phase shift nito is 0 degrees, indicated din by the positive sign dun sa harap ng answer. Okay? Questions? Okay, so at this point siguro makikita niyo kung gaano kadali yung magiging fourth exam ninyo. So, more or less ganyan lang yung mga magiging questions. And syempre kailangan naintindihan niyo rin kung paano gamitin yung golden rules. Okay, so yun yung idea doon. Okay, so next page. So determine the approximate values for each of the following quantities, okay, in figure 44. So sa figure 44, we have this circuit. Okay, anong klaseng circuit ito? So this is an inverting amplifier. Okay. So sa inverting amplifier or sa problem na to, pinapahanap yung input resistance, yung feedback resistance, and yung output na voltage. Okay. And yung closed loop gain. Okay. So pag sinabi closed loop gain, yung mga expressions na nilalagay natin dito, okay, lahat yan ay closed loop gain. Okay. So ito, yan. Okay. It's a closed loop gain kasi kino-close nyo yung loop between the output signal at saka yung input signal. Okay. So yan. And then, pag open loop gain, alam natin na na ideally, it's infinite. Okay. But dun sa data specs, okay, sa data sheets, okay, makikita nyo dun kung ano talaga yung actual na gain, actual na open loop gain nung amplifier. So, letter A, ano yung input na current? Okay, so yung input na current is simply given by the input voltage divided by the input resistance. Okay, ang input voltage is 1 volt. Diba? Tapos ang input resistance ay 2.2 kilo ohms. So 1 volt divided by 2.2 kilo ohms. So ang sagot dito is 45.5 milliamperes. Letter B, ano yung feedback resistance? So ang feedback resistance ay feedback current. Ang feedback current ay kinukuha yung output. Kinukuha yung voltage from the voltage output, from the output terminal. Okay, and dumadaan siya dun sa feedback resistance. Okay, so this is RF. Ngayon, ang output voltage, hindi pa natin alam. Right? So we need to figure that out first. But we do know na yung feedback resistance is just a negative of the input resistance. Okay? Kasi, di ba, dahil sa golden rule number 2, at this point, dapat zero yung voltage. Bakit zero yung voltage yan? Kasi itong terminal na to is grounded, which means na this is also grounded. So this should be equal to 0. So dapat yung current na dumadaan dito will cancel with the current na dumadaan dito. Okay, so this means na ito ay equal sa negative 45.5 milliamperes. Okay. Okay, so letter C, pinapahanap naman yung output voltage. Okay, and from here, pwede natin makuha yung output voltage to be P out, equal to negative of yung input resistance times RF. Okay, yan ay equal sa negative 45.5 milliamperes. Okay, so pwede rin feedback ay hindi, input. Okay, so input. negative 4.5 milliamperes times feedback resistance na 22 kilo ohms. Okay. So this will give us negative 10 volts. Okay, if you're going to write it in this way, in terms of the feedback current, dapat isulat siya ng ganito. Okay. Remember that the feedback current is the negative of the input current. Okay, so dapat isulat niyo siya ng tama na ganyan. Okay? So your output voltage is negative 10 volts. So which means na yung closed loop gain, okay, so for letter D is equal to V out over V in. At ito ay negative 10 volts. Tapos ito naman ay positive 1 volt. So ang closed loop gain is negative 10. Okay, so merong phase shift na 180 degrees as expected kasi itong circuit na to is an inverting amplifier. Okay. Okay, next. So draw the voltage waveform for each of the tawag dito, for each circuit with respect to the input. Okay, so draw the voltage waveform. Okay, so anong klaseng muna to? Anong klaseng tawag dito? Circuit muna to. Nalala niyo ba? Pwede niyo tignan sa notes niyo ulit para malaman niyo para ma-recall niyo kung ano yung klaseng circuit. Anyone? Walang may guess. So, this is called a comparator. Okay. And if you recall, ang ginagawa ng comparator is simply kinocompare niyo lang yung input at saka yung dalawang input signals. And yung output will always be maximum. If the input dun sa inverting input ay inverting input terminal ay grounded, then yung reference nyo ay ground. Pero dun sa second case, yung inverting input ay may reference na 1 volt, then yung anong tawag nyo rito, yung signal ninyo ay tawag dito magmamax lang with respect dun sa 1 volt na reference. So if we take a look at this is tawag dito, ang reference dito is 0 or ground. Then ang magiging output dito is positive ito. Maximum kaagad siya. Okay, hanggang dito. Okay, and then dito. Okay. So, yan yung output na signal. Now, in this case, meron tayong reference na 1 volt. Okay, so ang amplitude ng peak is 2 volts. So, ang reference natin ay kalahati niyan. Okay, so, which means na pag lumalagpas siya above 1 volt, saka lang siya magmamax to the positive. And pag lumalagpas siya below the 1 volt signal, saka siya mag-negative. Okay? So, i-extend ko lang ng konti itong itong blue para lang Magkaroon tayo ng konting reference. Okay. Yeah. So, ano magiging output dito? So, magmamax lang siya pagdating sa paglagpas dito sa 2 volts. Okay. And then, dito naman, oops, magmamax siya paglagpas sa 2 volts. And then dito naman, nangyayari. And then dito naman mag-max siya to the negative. Pag below 1 volt siya. Okay, so yan yung output signal niya. And itong output signal will be V out. Okay, 10 volts. Okay, so hindi pala to scale. Meron palang ano dito, V out max. So kung i-redraw natin ito, well, huwag lang natin i-draw. Sabihin lang natin na plus 8 volts, ito ay negative 8 volts. And in this case, ito naman ay plus 10 volts, ito ay negative 10 volts. Okay, so ganun yung andyan. Magiging output na signal. Okay. Ano, madali lang, di ba? Okay. So, ito namang circuit na ito. Anong klaseng mga circuits yan? Anong klaseng amplifiers to? These are called what? So, itong circuit na ito ay tinatawag na summing amplifiers. Okay. So, ang ginagawa ng summing amplifiers ay sinasum niya lang yung input voltages. Okay. Now, yung first circuit na nasa left, letter A, okay, yung mga input resistances ay pare-pareho. Ay pareho with the feedback resistance. So, yung gain dito is 1. Pero dun sa second circuit, sa letter B, yung feedback resistance ay hindi pareho dun sa mga input resistances. Pero yung input resistances ay pare-pareho. So you expect to have a gain dito sa circuit na ito. Okay, so let's answer letter A first. So how do we solve this? Okay. So the output is simply given by negative V in 1 plus V in 2. Okay, ito ang tawagin natin na V in 1. Ito ay tawagin natin V in 2. So this will be just equal to negative 1 volt plus 1.5 volts or negative 2.5 volts. So yun yung kanyang output voltage. Okay, now for this case, okay, so kung tatawagin natin itong V in 1, so V in 2, tsaka V in 3, okay, then ang magiging sagot dito ay yung output voltage ay equal sa, since hindi pareho yung feedback resistance at saka itong mga input resistances, so this will be equal to RF over R input times V in 1 plus V in 2 plus V in 3. So this is equal to negative 22 kilo ohms divided by 10 kilo ohms times yung V in 1 is negative 0.1 volt. V in 2 is 1 volt plus V in 3 na 0.5 volts. So yung V out ngayon ay equal sa negative 3.08 volts. Okay. Questions? Okay, so wala. Okay, so what about this? Anong klaseng circuit ito? So yung feedback element ninyo ay capacitor. At yung input element is a resistor. Input circuit element. Okay, so anong klaseng circuit ito? So this is an integrator. Okay. Okay. Okay, so sa sa isang integrator, okay, ano yung equation na ginagamit natin? Okay, so if you recall, sa notes ninyo, it's delta V over delta T, delta V out. Ay equal sa negative V in over RC. Or RC ay yung time constant. Okay. So we can solve for the time constant from the given values of resistance and capacitance. So 0.022 microfarads times 56 kilo ohms. And this will give us 1.2 milliseconds. So ibig sabihin ng 1.2 milliseconds na yan is from this point to this point, okay, tumataas yung signal niya. So yan yung 0 and then ito yung 1.2 millisecond na time. Okay. So yan din yung ina-expect nyo na output. Okay. So, ang tinatanong dito, rate of change of the output voltage. So, ninahanap is actually this one. So, this is equal to the input, which is 5 volts divided by 1.2 milliseconds, which is the time constant. So, ito ay equal ngayon sa negative 4,000 volts per second. Okay. So, yun yung rate of change of the output voltage. Negative 4,000 volts per second. Yep. Okay, so may mga sumasagot pala. Hindi ko napapansin. Thank you for your answers. Okay, then next. So ito naman, anong tawag sa circuit na ito? So this is a differentiator. Okay. So ano dapat ang output voltage ng differentiator na ito? And draw its waveform in relation to the input. Okay, so from yung equation na derive sa last meeting, yung output voltage ay equal sa negative VC over T times RF times C. Okay. So dito, okay, nag-i-increase yung voltage from 0 to 5 in 5 microseconds. Okay, so pag nilagay natin dito na 5 volts, okay, ibig sabihin, ang ilalagay natin dito ay 5 microseconds. Okay, kasi yun yung rate ng increase niya. Okay. from 0 to 5. Okay? And then yung feedback resistance ay 10 kilo ohms. Tapos yung capacitance ay 0.001 microfarad. Okay, so equal ngayon to sa negative 10 volts. So yan yung output na voltage. And alam natin na tawag dito, magbibigay ito ng output na square kasi di ba if it's a constant and you differentiate that, if it's a linear function, then you differentiate that, then you get a constant. Pero may negative sign ka dyan, so isi-shift niya yan out of phase by 180 degrees. So instead of a positive signal from 0 to 5, you get a negative square wave from 0 to 5. Okay. And then, dito ka magkakaroon ngayon ng positive na square wave from 5 to 10 microseconds. Okay. And yung output nito is negative 10 volts. At ito naman ang output is plus 10 volts. Okay. Sige, next. Ilang questions? Okay. So next. Okay, so anong klaseng circuit itong nakikita niyo ngayon? Okay, so diniscuss natin ito last time. Naalala niyo ba ang tawag dito? Okay, hindi niyo maalala ang tawag? So this is a triangular wave oscillator. Oops. Okay, so anong ginagawa ng triangular wave oscillator? So nagpo-produce siya ng dalawang types ng signals. Okay, ano-anong mga signals yung pinoproduce niya? Okay, so ang unang signal na pinoproduce niya ay a square wave, okay, which you can get here at this output. So this produces a square wave. Dito sa output na ito, ang nakukuha natin signal is the triangular wave. Okay. So, anong klaseng tawag dito? Ano equations na ginagamit natin dito? So, dun sa notes, first of all, makukuha natin yung frequency ng oscillation, okay, from this equation gamit itong R3 tsaka R2. So 1 at saka R1, sorry. So 1 over 4 R1C times R2 over R3. So this will give us 1 over 4 times 22 kilo ohms times yung capacitance na 0.022 microfarads times R2, which is 18 kilo ohm, divided by R3, which is 18 kilo ohms, 56 kilo ohms. Okay. So, ang tawag dito, madali lang na maintindihan ito equation na ito. Actually, ito yung resonant frequency. Okay, dahil dito sa feedback capacitor at saka dyan sa R. And this is nothing but your sort of your voltage divider. Okay. Yeah. So ganyan kinocompute yung frequency. But it's not a voltage divider per se kasi frequency yung output mo dito or frequency yung hinahanap. So if you solve that, ang makukuha niyo dyan is 1.6 kilohertz. Okay, so yan yung output na frequency. Okay, so show how to change the frequency of oscillation to 10 kilohertz. So paano natin makukuha yung oscillation frequency? How do we change the oscillation frequency to 10 kilohertz? So ano ang pwede nating baguhin dito? Okay, marami tayong pwedeng baguhin. Pwedeng R1, pwedeng C, di ba? Pwedeng R2, R3, di ba? So, ang isang pwedeng baguhin, of course, is R1. So, ang gawin natin is isolate natin yung R1 from this equation. Okay, and then we have now 1 over 4 R1, 1 over 4, 1 over 4 FC times R2 over R3. So, ang ibibigay sa natin ito ay 4, and then babaguhin natin to 10 kilohertz, di ba? So, 10 kilohertz. And then yung capacitance sa 0.022 microfarads times R2, which is 56 kilo ohms over 18 kilo ohms. Baliktad pala to. R2 is 56 kilo ohms, and then R3 is 18 kilo ohms. Okay, so R1 should then be 35 kilo ohms para mabago natin yung frequency of oscillation. Okay. Okay, now, hindi ko alam kung diniscuss sa inyo sa lab, pero you will not find 35 kilo ohms na resistor. Okay, pero may makikita kayong 36 kilo ohm na resistor. Okay, so yan ang gagamitin ninyo, resistance. Now, just for completion, tignan lang natin kung ano yung output voltage dito. So, yung output voltage ay equal sa plus or minus yung maximum voltage. Okay, times 18 times R3 over R2. Okay, so nandun lahat sa book yung equation na yan. So, dito hindi pa binigay yung maximum voltage. Okay, or you can solve yung maximum voltage base dito. Yeah. So, plus or minus V max times R3 is 18 kilo ohms divided by 56 kilo ohms. So, this will be plus or minus 0.32 V max. Yan yung output na. Yan yung output na voltage. Okay. Questions? Yung Vmax is dictated by kung ano man yung source voltage dito. Okay. Yes. Thank you for the answer. No, kakasabi ko lang, yung Vmax ay tawag dito. Magdedepend sa kung ano yung source voltage. Okay. Yan yung Vmax. So kung yung source nyo is plus 12 volts, then minus 12 volts. So yun yung ilalagay na Vmax dyan. Okay, good. Okay, then next problem. Okay, so this one is a bit interesting. Okay, kasi now we will see how itong summing amplifier can be used in an actual tawag dito, in a simple computer. Okay, so this is tawag dito a circuit. Okay, this summing amplifier can actually be used as a digital to analog converter. So yan yung ibig sabihin ng DAC dito. Digital to analog converter. So ano ibig sabihin ng digital to analog converter? Okay. So, of course, ang computer, ang bibigay sa inyo yan is a digital signal. Okay. And then kailangan nyo yan i-convert into an analog signal, meaning ano ba example ng analog signal? So yung signal na directly connected sa or directly measurable from yung output from yung output socket. Okay, mga analog signals yan. Okay, pag nag-build kayo ng circuit, nag-build kayo ng power supply, analog signal yan kasi directly connected yung input niya sa socket and then meron lang kayong tawag dito circuit, kay power supply circuit na ini-step down yung voltage, di ba? So analog signal pa rin yung output nung ano niyo, nung power supply. Okay. Now, ang tawag dito, so meron kayong ginagamit na Arduino, no? Hindi ko alam kung ginagamit ito sa lab. So, yung Arduino converts yung analog signal to a digital signal that the computer can read. Conversely, you can also let the computer, okay, send a signal through the Arduino, okay, tapos it will give you an output, which is also digital. Okay. Now, you can convert that digital signal to an analog signal using itong mga ganitong klaseng circuits. ADAC, a digital to analog converter. Of course, meron ding ADC, so analog to digital converter na circuits. So basically, ito yung ginagawa nung anong tawag dito, nung circuit na to. Kasi yung input signals ninyo dun sa summing amplifier are digital signals. And yung output signal ninyo is an analog signal. So you can think of this as a 4-bit computer kasi meron kayong 4 input terminals. Each input terminal corresponding to 1 bit. Okay? Pag sinabing 1 bit, it's 0 or 1, di ba? Ganun lang naman pag computers, pag classical computers, di ba? It's either 0 or 1. Okay, so, or 0 or 5 volts, or 0 or 10 volts. Okay. Yung role ng ano dito is, in this case pala 0 or 5 volts na nakalagay dyan. So 0, 5. Okay, yung role ng tawag dito, nung summing amplifier dito is to convert it to an analog signal. So what do we expect to get here? Okay, so halimbawa, tignan natin itong unang case na to. Okay, so dito, okay, sa case na yan, we have a signal, okay, that is turned off, nasa 0, nasa 0, nasa 0, and nasa 0. So in digital electronics, okay, that corresponds to, okay, so kung iikot ko, no? So this is D3. So this will be D3, D2, D1, D naught. Okay, so D3 is 0, D2 is 0, D1 is 0, and D naught is 0. Okay, and pag ginamit natin itong amplifier na ito, so if this is 0, 0, 0, 0, wala kayong ina-add, diba? So yung output nyo is also 0. Okay, so dito ko nilalagay yung output para may konting space. So yung output voltage nyo is 0 volts. Okay? Now, what about itong 1? So this is, dito may 5 volts ka. Okay. Tapos, dito, meron kang 0, 0, 0. Okay, so D3 is 0, D2 is 0, D1 is 0, and D naught is 5 volts. Okay, tatanggalin ko na muna yung units para hindi sumikip yung ano. Okay, so if that is 5 volts, okay, so 5 volts divided by 200, yan yung current na dumadaan dito. Right? So yung current, okay, through I naught, okay, is 5 volts divided by 200 kilo ohms, which is equal to 0.025 amperes, milliamperes, okay, or 25 micro amperes. Okay. Now, yung corresponding na output dyan, okay, ay makukuha natin from the feedback resistance. Okay, so, at saka sa I naught. So, yung output signal dito is yung feedback resistance times yung I naught. Okay, remember, this is just an inverting amplifier. Okay, so we're using the same principle as an inverting amplifier. So, ang feedback resistance is 10 kilo ohms. Okay, and then we have an I naught of 0.025 milliamperes. So this will give us negative 0.25 amperes. Okay, so yan yung ating output na voltage na yan, negative 0.25 volts. Okay, so pag sinulat natin siya dito, so we have negative 0.25 volts as output signal. Okay, so next, dito naman sa 2, okay, so gamitan natin ng konting shade para hindi siya confusing. Okay, so ito yung una. Okay, then ito naman yung pangalawa or pangatlo. Okay, so we have 0, 0, and then dito may 1. May 5 volts ka na signal, then dito 0. Okay, so ano ngayon yung output dyan? So yung D1 ngayon yung dito, yung present. So D1, ang resistance niya is 100 kilo ohms. Yung input resistance sa D1 is 100 kilo ohms. So we have I1 equals 5 volts divided by 100 kilo ohms. Equal ngayon ito sa 0.050 milliamperes. So yung corresponding output voltage dito is negative RF I naught, I1 equal to negative 10 kilo ohms times 0.050 milliamperes. Or this gives us negative 0.50 amperes. Volts. Bakit ampere nilalagay ko dyan? Okay. So going back here, we then have negative 0.50 volts. Okay? So for the third, okay, ano nang meron tayo? So this is 0, 0, and then 5, tsaka 5. So 0, 0, 5, tsaka 5. Okay, so anong ibibigay sa atin yan? Remember, this is a summing amplifier. So, ang meron ka lang is dito sa D0 at saka D1. Ito ay 0 pa rin, 0 pa rin. Okay, so, if this gives you 5 volts, you also have 5 volts here. Okay. Then you have a total current of 0.025 plus 0.050 milliamperes. So yung output voltage mo dyan ngayon is just the sum of the input voltages. So we have negative 0.75 volts. Okay. Then sa next, here we have 0, and then 5, and then 0, 0. 5, 0, 0. So now we have just D2. So ang D2 ngayon, it comes from here. So ang current dyan, which is I2, ay makukuha natin from this expression. Okay, so this will give us 0.100 milliampere. Okay, and yung V out ay equals to negative RF times I2. So negative 10 kilo ohms times 0.1 milliamperes. So this is negative 0. Or negative 1 volt. Okay, so yung output dito is negative 1.00 volts. Okay, so for 5, we have 0, then 1, 0, 1, 5, diba? 0, 5, 0, and then 5. So you have D naught tsaka D1. Ang D naught is negative 0.25. Ang D1 is 1 volt. So this is negative 1.25 volts. Next, we have this. Okay, in this case, we have 0, 5, 5, 0. 0, 5, 5, 0. Okay, so anong makukuha natin dito ngayon? We have D2 tsaka D1. Ang D2 is negative 1 volt, 5 volts. D1 is 5 volts, pero yung output niyan is negative 5 volts, negative 1 volt, at yung output nito is negative 0.5 volts, right? So this will become negative 1.50 volts. And then dito naman sa 7, we have 0, 5, 5, 5. So, i-add natin yung outputs nitong tatlo, we get negative 1.75 volts. Okay. Then, we do this. Okay, pagdating dito, we have 5 volts para sa D3 and then 0 para sa rest. Okay, so in this case, makukuha natin yung I3, which is the current through input D3. So 5 volts divided by 25 kilo ohms equals to 0.200 milliamperes. And yung corresponding na output voltage dito ay equals to negative 10 kilo ohms times 0.200 milliamperes or negative 2 volts. Okay, so, yung output mo to ngayon is negative 2.00 volts. Okay, so should be straightforward na yung the rest. So ito ay 5, So 5 na to actually lahat hanggang dito. So 5 volts, 5 volts. Yan. And then here we have 0, 0, and then 5, 5, 0, 0, 5. So this gives us 2, and then plus 0.25, so negative 2.25 volts. Okay, tapos dito naman, ito ay 5, 0, 5, 0, 0, 5, 0. Okay, so this is 0.5 volts. So this is negative 2.5 volts. Ito naman ay 5, 0, 5, 5. So ito ay 0.25, ito ay negative 0.5. Tapos, ang magiging sagot dito ay negative 2.75 volts. Then, this is 5, 5, sorry, 5, 5, 0, 0. 5, 0, 0. So, dito, 1 volt siya, so negative 3 volts. Then dito naman is 5, 5, 0, 5. Okay. And that gives us negative 2, negative 1, negative 0.25. So negative 3.25 volts. And then ito ay negative, ito ay 5.550. So this gives us ito ay 0.512. So negative 3.5 volts. And then finally, we have 5.555. So this gives us negative 3.75 volts. Okay, so anong magiging actual na output nito? Okay, so anyway, I hope na naiintindihan niyo kung paano na-derive itong mga, itong mga voltages na yan. Okay, so ano magiging actual na output nito? Well, yung actual na output niyan ay magiging parang ganito yung itsura. So dito nakamap na yung yung outputs versus yung input. So this time, it's not written in terms of yung input voltages, but instead it's written in terms of yung binary input. What this means is that every time you see a 1, it means that the input is, tawag dito, is 5 volts. Okay. And ganun pa rin yung, yung notation. So this is D3. So lahat ng nasa column na to is D3. Lahat ng nasa column na to ay D2. Lahat ng nasa column na to ay D1. At lahat ng nasa column na to ay D0. So if you see a 1 here, then that means yung D0, yan yung 5 volts. And if you see a 1 here, then yung D1 yung 5 volts. If you see a 1 here, then yung D2 yung 5 volts. And if you see a 1 here, then yung D3 yung 5 volts na input. Okay, but this time it's just written in binary. Okay. So yung corresponding na outputs niya ay nandito sa y-axis. Okay, so what will it look like pagdating sa pag halimbawa nagsaksak kayo ng oscillate ng anong tawag dito? Ang tawag doon? Anyway, pag sinaksak niyo yan, ano makukuha niyo yung hindi function gen. Oscilloscope. Okay, pag nilagay kayo ng oscilloscope. Okay. So ano magiging itsura niyan? Well, you won't see itong mga steps na to, but instead, you'll see a straight line na pa ganyan. Okay. So that's how you get that's how you convert a digital signal to an analog signal. Okay. Okay. So any questions? Any questions? Okay, so now medyo nakikita niyo na yung kung paano siya, kung paano gumawa ng computer essentially, di ba? Based on these circuits. So may transistors ka, and we use these transistors to build operational amplifiers, and we use these operational amplifiers to build simple like tawag dito, computers such as this, a digital to analog converter. Okay, a computer that adds, 'di ba? Yung mga input signals ninyo. Okay, and converts the digital signal to analog signal that you can use then. Okay, so any questions? Okay, so we'll stop here. Okay, but if you notice na itong last na exercise is already an introduction to digital electronics at yun yung pag-aaralan natin sa Wednesday next week. Okay, so magpo-provide ako ng ibang reference for that. Hindi ko pa ina-upload sa Google Drive, but I'll let you know pag meron na. Okay, so if you have no questions, then ito, hanggang dito lang tayo, and we can tawag dito. And then I guess I'll see you again later sa 181. Okay.